Hello and welcome to the Geographic Calculator webinar for the month of December. Currently, all attendees are in listen-only mode, and you should be able to see our first slide on the screen. I'm Jasmine Bird, an application specialist here at Blue Marble Geographics, and I'm here with Sam Knight, Director of Product Management.
Good afternoon, everyone.
Today we're going to talk about topics related to common oil and gas workflows.
That's right. Today we're going to be talking about a few different parts of the Geographic Calculator. We're going to be focusing on several different topics, from seismic data and conversions of both coordinates and file types, streamlining those files that can sometimes be a little bit tricky. We're going to take a look at our area calculation tool. So we're going to be looking at some area polygon data from a couple of different sources. And we're going to be taking a look at interacting with the Geodetic Datasource. So one of the very common things in the oil and gas world is manipulation of custom projections and filters to streamline how your folks are working with all of the various definitions that are in the Geographic Calculators database. And we're going to be doing that through several different interfaces in the application. We're going to take a look at the interactive conversions job, specifically for some of the envelope tools within the Geodetic data source. We're going to take a look at the specialty job, the seismic data converter, for those seismic types. We'll also take a very, very quick look at the point database job for one particular type of seismic data. We're going to take a look at another specialty interface, which is the area calculation tool. Some folks call that our lease area calculator. Can be applied to lease areas, as we'll see, but it is a generic area calculation tool. And we're also going to take a brief stop into our administrative settings, which is really a subgroup of settings under our options menu.
If you have any questions during the presentation, you can use the questions tool on the GoToWebinar panel to the right of your screen. Our panelists will try to answer your questions as they are submitted, and the presenter will address any outstanding questions at the end of the presentation. We will also set aside some time at the end for questions and answers.
And also during the session and after the fact, if you have a more complicated question or if you don't think of something till afterwards, you can always use our support email address, which is at the bottom of the screen, geohelp@bluemarblegeo.com. We can follow up after the fact there. And Jasmine, we've also got some upcoming events that we're going to be at.
Yes, we'll be at a few conferences next month. On January 11th, we'll be at the Pennsylvania Society of Land Surveyors in Hershey, Pennsylvania. On January 22nd, we'll be at the Wisconsin Society of Land Surveyors Institute in Wisconsin Dells at Wisconsin. So if you would like to meet any of our Blue Marble staff, please attend.
Okay, let's get started here. So we're going to hop over into the Geographic Calculator interface, and we're going to be taking a look at a couple of things. So we're going to take a look at the interactive job here. We're actually going to come back to this a little bit later. I'm going to actually start out getting right into seismic data conversions and point database conversions, see how they're related, how they're a little bit different. Then we're going to jump over. Jasmine's going to talk about our lease area calculation tool. We're going to talk about a couple other little widgets as we go, and we're going to wrap it up at the end, hopefully about 45 minutes from now, talking about the administrative controls, updates from Epsg, spatial filters, and things like that. So if you are new to the Geographic Calculator, you may notice at the very top of the screen, mine says Geographic Calculator 64-bit 2013 SP1, that's Service Pack 1. The version of the application that we're dealing with today, 64-bit versus 32-bit, there are zero differences between the capabilities of 32 and 64. The 64-bit version is just going to be a little bit faster on that 64-bit architecture machine if you have that available, but you will have the capabilities to do everything you're going to see today in our workspace here. There are no functional differences in the types of data that we can handle between there. So you'll notice down the left-hand side of my screen, I have our Project Manager panel, and I've got a lot more stuff in my Project Manager than you probably see when you start up yours out of the box. All of these extra jobs out here, these aren't extra capabilities. This is just simply a workspace that I have actually predefined to showcase various types of data. So you have the same ability to generate this long list of particular jobs, and these might be templates. They might be little one-off conversions where you have very particular coordinate system settings. But there's nothing special about these other than the fact that I happen to have a lot of them here just for showing some of these different bits and pieces. I mentioned I'm going to start off here on the seismic survey converter. This is one of the really sort of heavy hitters for folks that are in the oil and gas industries. What you'll see is a spreadsheet style interface here, and this is actually going to be very similar in appearance to the job that's right above it there, the point database conversions. So I'm just going to click in between there. You'll see I have an Excel sheet in the point database job, and back in the seismic survey job I have a seg file. This happens to be a segp1 file of the 1990 specification. Now it looks like very cleanly formatted rows and columns, and that is simply because we're handling it as a predefined type. For those of you who are not familiar with these, they are actually an ASCII data source, so they resemble simply a text file. There are no clean column breaks anywhere in there. The numbers are all packed together. They're very difficult to read until you break them out into this spreadsheet style interface where we can very clearly see things like our latitudes and our longitudes and our northings and eastings, or rather eastings there in C7 and northings in C8. Now, the seismic data converter has a few little differences between the point database job and the seismic job. One, for those of you who are familiar with the interface, you'll notice that there are a couple extra coordinate system settings over here on the output side, and there's actually a couple of buttons missing from this interface as well. So I'll just click back over to the point database job very quickly here, and you can see there is a column settings button that we're actually missing on the point database conversions that we see over here on the seismic job. Now, the reason for the seismic job in the first place is because there are some nuances to loading these types of data and performing conversions in them. One is that the data must be in a very specific structure in order for it to follow the specifications of those seismic types. So in particular, one of those specifications, and I'm going to try and use my highlighter tool here, we're going to see these four columns here right across the top of the screen, C5 through C8. Those four columns very specifically always contain the latitudes and longitudes. So here in C5 and C6 we have our latitude and longitude columns, and C7 and C8 have our easting and northing columns. The order of those is very particular. It goes latitude, longitude, easting, northing, always, no matter what. So there's no flexibility there within the specification of this type of data to support that column order. So we don't need to actually set the column order like we do in our point database job. And the reason for that is because of these specific types. So within this data type, we don't have to worry about column settings, but because we always have those two sets of coordinates involved here, we always have lats and longs, and we always have northings and eastings, we've got two possible coordinate system settings for output. So we'll have these checkboxes to either toggle on or off any of those given components. So we always have the placeholders for those columns, whether or not we actually have the data. So we don't have to update both of those, but we can optionally update both of those in one pass. In previous versions of the software years ago, we didn't have this seismic tool. So all of this data had to be handled in the context of the point database job, and it actually took multiple passes in order to complete multiple conversions to update both latitude and longitude and the northing and easting projected system in some of these files. So we have now our double outputs here. We can convert from any system. So if we pick a latitude-longitude system, it's going to automatically read our source coordinates from the fifth and sixth column. If we pick a projected coordinate system instead, it's automatically going to read from the seventh and eighth columns in there. So it has a little bit smarter handling because the data must be in such a particular structure. Now, the real nuance of the data is actually in reading this data in. And what we're going to do is take a look at the process of loading this in here really quickly. So what I'm going to do is I'm going to reload this same file. So I'm just simply going to grab onto my segp1 file here, and this is a sanitized demo file that I've got. It did actually come from real data once long ago, but we've since cleaned it out, so it's non-proprietary, non-specific to anybody's operation. When we load this in, you'll see a little prompt, and you can optionally toggle this off if you have a common preference, so that it just will do whatever you choose in the future. It asks you if you want to use the selected scheme, the default scheme for the file that you've loaded in, or if you don't want to use the default scheme. So in this case, we'll just say, yeah, let's go ahead and use that default scheme. Loads our data file back in, and we can take a look at things like the headers for that data. And in this case, we're going to see that we have quite a bit of complete header information, but we see some trouble with the header as we get down towards the bottom of this file. You'll see that there are actually data rows. This is actually rows of shot points that we have appearing out of place. So they're falsely being recognized as header data. And so this is where we get into the alternate load method of not using the default scheme, where we actually need to sort of patch up the structure of this file so that it more cleanly follows the specifications for the seismic types. So I'm just going to reload that one more time. I'm going to come back to that first dialog that we saw. Do I want to use that default scheme? And this time I'm going to say no. Let's step into the wizard, and this will let us see exactly how this file is being read. So we can see that the type of data that's being recognized, in this case, this is a segp1 file, the old 1990 specification. The particular file, the preview that we're looking at is the file that we've selected. And we can scroll down in the data file itself. So we'll scroll down towards the bottom of that header section, and we can see that we've got that chunk of header that was falsely appearing in there. So we'll go to the next screen where we're recognizing those header records. In this case, we'll see the header records are beginning with an H. So every row that starts with an H is being recognized as header. And there's this setting in here called block length. Block length is basically a computer data storage term for the number of rows, basically. So basically 20 rows starting with an H are going to be recognized as blocks of a header file. And this is the normal scheme for importing these files. So according to the seg specification, there should only actually be an H on every 20th row of that header. And in this case, we've got a seg file that has a very common modification to it, where there is an H on every row, which is actually the default scheme for a different seismic format called UCOA. So there's a little confusion here between a lot of these things, and very often we need to clean up these data files. So what we can do here is a few different things. We could specify the total number of header rows. We could use the little counter here on the right to say that this file has 67 rows of header. We could set it to records above the first blank line, because we do have a nice blank line there to be recognized. Actually, there's an H on there. That might trip that one up. Or we could simply specify a different block length. So I have an H on every row. So what I'm going to do here is just simply say that my block length is 1. And when I change that, you'll see the highlighted rows of where the header is being recognized are going to drop back just to those top chunk of the file. So in this case, I can make one simple change, and that's all I need to do. If we actually needed to mess with where the column breaks were appearing, we could use this next screen, and you'll see all of the red lines superimposed over our data are actually where those column breaks are dropping in the data. And if they were in the wrong place, we could simply drag and drop those red lines to put them where they need to be. In this case, all of my columns are in the right place. It's just my header that's a little bit messed up. So I've tweaked my header, and I'm going to go ahead and hit finish, and we're going to reload that data again. And now, if you were paying attention very closely at the beginning, you'll notice that my third column here, which is actually the shot point number, has dropped back. It was starting off at a higher number there, but now it's back down to 101, which is actually the beginning of this line. And if I take a look at the header, we see all that same information that we had before, but if we scroll to the bottom, you'll see that there are now no data records being recognized as the header information. And so we can just simply go right along here, update whatever coordinate system settings we need to put in place. If we need to add any comments, things like that, we can edit right here live in the header editor and say OK when we're happy with our edits. Now, to actually complete the conversion on this, if we wanted to, let's say, validate the coordinates in column 7 and 8 from the coordinates in column C5 and C6, what we might want to do here is convert from WGS84, which according to the header is the coordinate system for the lat and long columns that we have in there. And we could update just the projected output coordinates. And I've already set that to UTM zone 38, which is also, according to the header, what the coordinate system should be. So I can take a look at our output formats, make sure that everything is set as we expect. In this case, I might just need to drop back my grid coordinates decimal precision to 0. In this case, these are going to be completely rounded off to whole meters in the current data file structure. And we can actually then go on and complete that job. All we have to do is give that a place to go. And I'll just simply save this into a desktop folder that I have here called Output. And you'll see the type for that automatically recognized from the input type. So we loaded this as a segp1 file. We modified its scheme on the way in, but now I'm going to write this out as a standard segp1 file. So this is all going to do the conversion for us. It's actually going to clean up the data at the same time. So it's going to clean the output data of the file, and it's going to write us a new file. So hopefully the header and all of those updated columns will be in place. We can preview that conversion. You'll see all of our updated coordinates dropping into place. And then if we want, we can actually go ahead and process that and write out the complete file as a new file after we've made sure that our preview is all nice and clean. I'm not going to bother going ahead to write that whole file out there, but I just wanted to take a look here at the seismic data conversions job. Now, there are a number of other types of seismic data here that we support. So segp1 is just one of those. We also support the UCOA P190 types, SPS, seg-y, the newer OGP formats as well. I am just going to take a quick mention here of the seg-y format, and I'm going to click down into another predefined job that I have set. As this data loads up here, let me just get a little more interface space on screen. The seg-y format in particular, this is just sort of a temporary note. The seg-y format is found on the point database job rather than the seismic survey converter job. We will be moving this over in the future. But for now, it is implemented most smoothly on the point database conversions job. As you load in a seg-y file, you will notice that we actually update all of the column numbers, or column names rather, excuse me, at the top. That allows you to very easily set the column settings. But the reason for the handling on the point database job is simply that there might be multiple sets of coordinates beyond just the two coordinate fields that we have in the normal seismic types of segp1, UCOA, and so on. So if you're looking for seg-y data conversions, the process is largely going to be the same. We're just going to find that in a slightly different place on the interface. And I think at this point I'm going to hand it over to Jasmine, and she's going to take a look at the lease area calculation tool that some folks know it as, or just simply the area calculation tool. Okay, Jasmine, I think I just gave you control of the mouse. Are you able to take control?
I am. Thank you, Sam.
Okay.
To access the area calculation tool, you just want to go up to the main toolbar here, go to Window, and then select Area Calculation Tool. And that will bring up the Area Calculation Tool window. This tool allows you to calculate area by entering points to describe a polygon, and what makes it a particularly accurate tool and useful for calculating areas or lease block boundaries is that you can adjust the method used for each segment defined between the points. So this can be particularly helpful when you're calculating a lease block boundary. When you have an area that straddles two different areas, an international boundary, for instance, where in one area the line might be defined as a geodetic or great circle line, and then in another area it might be a line of true direction or a grid line. So just to sort of run down the interface here, we have at the top you can calculate the area. You can decide which system you would like to calculate the area in. So you'll see that you can calculate it in either geodetic or projected system, and you will define the system down here. Let me move the window a little bit. You'll see this is where you'll input the points to define the polygon, and then you'll see that you can click here to select a coordinate system, or it might be recognized when you load in your data. Can you click on the coordinate system tab for me, Sam? Thanks. So here we'll see, should have seen this before. If you double click on this, it'll bring you to the Geographic Calculator Geodetic Library, where you can select a system if one or the correct one is not automatically recognized when you load in your data. Thanks. And I happen to know that my data is NAT 83, UTM zone 15. And let's see. Go back to area polygon, you'll see the point. So I'm going to just load in a sample file I have here, and it'll say open list. And I happen to have mine in an XML file named Louisiana. So then you'll see that the points here are defined. If you need to edit a point, you can double click to change the values. And up here, just to go over, there's trace spacing. This is the number that defines the spacing between points and line segments. The default is 1,000 meters. A smaller number will give you more accurate results, but it can slow down calculations. Here is where the calculated area will populate. If you change any of the path to next values, this is where you can change how the line is calculated from one point to the next. Then you'll want to recalculate. So we'll just kind of look at the options available here. Do you mind clicking on that drop-down menu for me, Sam? So we'll see that you have a geodesic, and this will create a line that follows a geodetic or a great circle from the starting point to the next point in the list. You can also select parallel. This will create a line that follows an east-west parallel to the next point. You can only use the parallel option if both points are on the same parallel and have identical latitude values. The grid option will allow you to create a line of true direction within that grid coordinate system. So for our demonstration purposes, we'll just stick with grid and hit calculate, and then you'll see that the results show in square kilometers. And over here to the right, there's some options for changing the grid segment appearance, or the parallel segment appearance, or the geodesic segment appearance. And if we scroll down a little bit, this is minimized, you'll also see that the geodetic and grid points are displayed differently. So now we have latitude and longitudinal values if we choose to. We can switch one to geodesic and calculate, and you'll see that how this particular line segment using the geodesic line changes its appearance based on what you have set here.
Okay, and so the only data that we've shown here so far is an XML file. Just to clarify, the data from that XML file was created from this interface. So we started off with manually typing those coordinates into the field at the bottom. Typically, these aren't going to be overly complicated, but Jasmine, do you want to show a way that we can get data in here from other places if you don't want to just type all those in here?
Yep. If you do not happen to have an XML file, just clear the list. And you're starting from scratch. You may have your points defined on an Excel file. So if you know that you want to use latitude and longitude, and you would like to use latitude and longitude checked when you import your lat-long values, you can have a column here that says true. If you know that you would like this particular column here in the area calculation tool unselected, then you would want to, in your Excel spreadsheet, have a column set to false. So we'll just copy. And then if you have that true or false column, you want to highlight use lat-long in the area calculation tool and then just hit Control-V. And you'll see that your latitude and longitude values pasted into the area calculation tool table with use lat-long checked for each set of coordinates.
Yep, and that's a very powerful tool for getting shapes in here from Excel in particular. And just to be clear on the checkbox there for use lat long, you don't have to paste in there. You don't have to have that true false column. You can also simply start off in the latitude column and paste directly into the latitude column, and then manually set your use lat long column. You can also paste into the easting and northing column. The only things that you do need to do are in something like Excel, where you're going to be managing the rows and columns of your data. You do need to have them matching the order that we use here in the application. This is one of the more rigid interfaces, so you do need to have it latitude, longitude, easting, and northing in this interface to most smoothly paste into that interface.
So just a quick note on the export options. If you want to save it as an XML file, if you have another Geographic Calculator user that you would like to share the list with, there's a few Save As options. You can select to save it as a Geographic Calculator area file, and you'll see that on the drop-down menu here. You can also save it as a vector file. That would be File, Export Geometry, and this option is only available after the polygon has been calculated, so you would have to have had calculated your area. Thank you, Sam. And then you'll see that you can save it either as using the grid or the base, and the base will be the ellipsoid coordinate system, which in this case is NAD 83.
Okay, thanks very much for that little demo there, Jasmine. We're going to keep it rolling on here with just a very quick tool. This is found under the Window menu. There's this little tool in here called the Linear Unit Converter, and this is actually an incredibly simple tool. This is something that a lot of folks in the oil and gas industry in particular asked us for, not necessarily for dealing with positions, but dealing with distances between points in all of these crazy different kinds of units that we have for all over the planet. This tool is really as simple as it looks. We're just looking at this one little window here in the center of my screen. We have an input field and there's an output field. This is as simple as typing in a value into that input field. So I'm just going to punch in 10 meters, and then on the output all we have to do is select the units that we're going to be converting that out into, and we can pick any of those other, there's about 90 some odd types of linear units that are used all over the world, deriving from the various survey standards that were used all over the place. So if we wanted to convert that 10 meters into, say, an international foot, if we're dealing with surveyors in another country somewhere, we might do that and simply calculate, and then it's going to spit out for us the output value. We can also fine-tune the display of that to the decimal precision if you are looking for those particular outputs. There's also just a simple optional toggle on whether or not you're going to display the decimal symbol if you were trying to match some implied precision that we have for various surveyors' shorthands formats. So that's the linear unit converter. That was a special request actually from a number of folks in the oil and gas industry. That's the only reason I'm mentioning it here today. Those are some of our main job interfaces that directly relate to oil and gas workflows. There's many, many others here that we could spend time talking about as well. But I'm going to focus just on one particular type of conversion, not necessarily to show the job itself, but to show the method that we're using in the job. There's a lot of stuff that's found in the Geodetic data source that ships with the application that folks need to have some control over in the oil and gas realms in particular, because we're very often dealing with remote parts of the planet where we may not be quite as familiar with the local surveying standards. There's many, many different systems out there for surveying in. There's many different options available, and we don't always know exactly which is the best option for our workflow. So we're going to be taking a look at some of our admin tools here and how those specifically relate to the folks in the oil and gas space. I'm going to start off by taking a look at filters in the data source. And to do this, I'm going to go back to our interactive conversions job here, which is really our most simple interface in the entire application. So this interface is for single point conversions. Simply numeric, one single point at a time. In this case, I've got a very simple latitude and longitude conversion setup, or a transformation in this case, because it goes between two different coordinate reference systems on different horizontal datums. And so what we're going to take a look at here are some of the different methods that we have for selecting transformations and simply how we navigate through the database of coordinate systems. So we are working on the interactive job here, but the filters that we're going to be taking a look at actually apply throughout the entire application. So what we're going to be starting off with here are just some simple on or off filters, and then we're going to get into what we call spatial filters on the data, and not on the coordinate data itself, but rather on the database of coordinate systems that we have. So to select a coordinate system, double-click on any of these typical controls here, and we have this optional pop-up that allows us to narrow down the coordinate systems we're dealing with by a map. I'm going to skip this for now. We're going to come back to that in just a minute. So I'm going to start by simply browsing the entire database. For those of you who are not familiar with the structure of the databases here, we have two database files that provide over 5,000 coordinate systems to the software. I mentioned there are about 90 some odd different linear units. There are about a dozen different angular units. There are over 500 horizontal datums. Over 2,000 coordinate transformations, many, many different ways to get at what we're looking for in here. Within coordinate systems and some other types, you'll see there are major classifications of those things. So fitted engineering coordinate systems, geocentric coordinate systems, geodetic, those are our lat longs. And then down at the bottom, we'll see projected. Those are all going to be things like our transverse Mercator, Lambert conformal conic projections, and so on. We organize those geopolitically. So first by continent, and then by smaller political regions in there typically. Now in the folder tree that we have, you'll see, if we click on North America, we'll see systems that cover large portions of that area. And if we drill down into the more localized folders, we'll see local variants of some of those systems. So I'm going to start here just simply with our main NAD27 system, continent-wide system used in North America. This is a latitude and longitude system. So I can pick my units, Down at the bottom, we'll see I have several different units to choose from there. I've got degrees, I've got grads, I've got radians, but there's actually some filtering going on right now that we don't necessarily see as the end user. And this is something that's particularly useful for folks who are in more of an admin role, or simply folks that are looking to step it up to the next level of geodetic data source management to help out other folks that you're working with here. So in my list right now, I've only got these 3 units: degrees, grads, and radians. Just a minute ago, I mentioned that we have about a dozen different types of angular units. So let's take a look at where we're going from a dozen down to 3. Under the Options menu, we have this whole section of the application called Administrative Settings. And these are a number of different tools to help provide both restrictions and guidance to users of the software to make better decisions. So first of all, what we're going to take a look at are our view settings. Now, I mentioned there are over 5,000 coordinate systems here in this database. This is the interface that we use to restrict how users interact with all of those various systems. So I'm going to take a look under our Angular Units type here, and you'll see that I've got now a dozen of those different types of units. But there's only 3 that are checked off under my Show column. So I have this simple checkbox column over here to show or hide a given type of a unit. This is a very common setting that I put in place for myself, just so I don't have to see a lot of the other more esoteric types of units that I don't commonly deal with. Large enterprise organizations where you're dealing with many other users, sometimes you can put in filters like this in place yourself to help streamline those selection operations. As well, we can apply that to any other type of geodetic parameter that we have in the database. If we take a look under Coordinate Systems and take a look under Geodetic, you'll notice that I've got a couple things that show up a little bit differently here. I actually have a couple of folders that I've hidden, and I don't know if anybody noticed as we were browsing coordinate systems, but you couldn't see any coordinate systems globally that were used anywhere in Africa, because I've actually got those shut off on my interface. It is completely hidden to the end user when these are turned off. They can't see them, they can't select them. And sometimes that simply allows folks to reduce the number of choices an end user that maybe doesn't have quite as much training geodetically, reduces the number of choices that they need to make to pick the appropriate coordinate systems. So there's a few different levels here. I've already shown the individual checkbox level there for hiding things, and you'll see these in italics here in my list. When you see italicized folders, that means the entire folder is hidden from view, and we can do that simply by right-clicking on any of those objects, and this will either say Hide Folder or Show Folder. So what I'm going to do is say Show Folder and turn Africa back on. Let's say Show Folder, turn Antarctica back on, and then you'll see all of the text of all of those subfolders and sub-objects actually come back to normalized text as well. I'll save that in place in my view, and when we're back out in the main interface trying to select a coordinate system, you'll see now I've got those folders that I had previously hidden in my interface. So through that mode there, you can actually streamline the interface specifically to suit your users in the parts of the world where they're operating in. That can be very useful for heavily international operations or folks that are particularly limited geographically. The very first company to implement the use of this tool after we rolled this out about 6 years ago now was actually a Canadian firm, and they operated very specifically only in the region of Calgary in the province of Alberta. And what they did for their users was come through here and they shut off all of the non-Alberta related coordinate systems. So they left themselves a few world projections and a few of the Canadian regional systems in that area, but they shut off everything like South America, Australia, and so on. Now the next thing we're going to take a look at is spatial filters. in the administrative settings again, we have this tool called Custom Envelopes. And the custom envelopes, let me just maximize my screen here so we can see what we're looking at. The custom envelopes are areas of interest where we can apply extra filtering, not just in a off or on mode, but in a bounding area mode. Out of the box, we actually provide a couple of these filters sort of over and beyond the base Epsg Datasource filters, but you're actually free to implement your own through either importing things like any vector file. You can import polygons on top of this and use them for your own filter, or you can simply custom draw your own on top. To show this, I'm just simply going to take a look at one of our existing areas. I'm going to click on this black polygon here that's surrounding the continental United States. You'll notice the red polygons in the background. These are simply a reference map for us, and the black polygons over the top of that are areas that we are supplying as a part of the base data source here. So I'm going to click on that area for the continental US, and you'll see up pops the custom envelope editor. We can apply a name for any of these. I might simply call this one CON-US for continental US, common abbreviation here in the States. We can apply a priority level there, where the lower the priority number, the higher the priority. And this is particularly useful in cases where you have overlapping polygons in border areas, or where you have places where more than one transformation might be applicable. But the real meat of this is in the filters. In the filters, this allows us to spatially filter the use of any of those particular entities within that area. Excuse me, just taking a drink there. Within those particular areas, we can filter on coordinate systems, datum transformations, or horizontal datums that are used within those areas. All of these have a very defined spatial component to them. I'm going to take a look under datum transformations in particular, and I'm going to search out those that are useful in the example we have back on that interactive job. And I'm just going to very quickly search out NAD27 transformations. Now you'll see that there are many different ways to make these transformations. We have a number of them that are defined for different parts of the world. You'll see this envelope column tells us in words where those are used. There's also a bounding box defined for those if we were to open up the full definition of those. But I can use this show or hide column to filter down to just those that we deem are appropriate for use within that particular area, and in this case the area of the continental US. You'll see I have one approved method for getting from NAD27 to NAD83. And if I scroll a lot farther down, you'll see I have some approved methods for getting to other datums, so things like WGS84. With all of those other systems or transformations shown, this is going to streamline the experience that the end user is going to have when they go to make these particular transformation selections. So I'm going to pop back out to the main screen. And we're going to see this in action on the interactive job right here. So with a NAD27 to NAD83 transformation, when we double click to select the transformation, specifically because we have defined a point to apply this transformation to, it's going to narrow down that list to only those that are combinations of approved ways to get between those two systems. So in this case, it's going to pare my list down to about 4 ways to get in there. And I can then sort those by accuracy, and we can very clearly see that of those approved ways to get between those two systems, I can use some extra tools like the accuracy column out there to help maintain the best possible transformation for that data. So it pares down the number of options that the end user has to choose from.
Sam, I have a quick question from the audience. Can these administrative filters that you've set up, can these be shared and distributed to other users?
Yes, they can actually be shared between other users. These wouldn't really be that useful in the sort of absence of being able to share them. Single users can use these by yourself, and as I do myself to filter out some of the choices that I see to speed up my own work. All of these filters are saved as a part of the overall workspace. Now, the workspace that we see here is a combination of things like all of the jobs that we have in the project manager down the left-hand side of the screen. But there are a number of things like custom envelopes, and these get into the preferences of the application. So in the preferences of the application, there are a number of locations of things like the custom envelope file and the workspace file and the data source, all sorts of different things like that. There are some fairly advanced topics in there, but the simplest way to share these with other users is under the File menu. You'll see we have some options here to export a workspace or import a workspace, and that packs up all of your user settings, all of the custom envelopes, your custom database file, and it gives you a single zip file that you can share with another user. They would then come back into the same menu, and they would say Import Workspace, and they would see all of the options that you had predefined for them. There are other ways to do this. Some folks will use workspaces that are shared on network resources that can be remotely administered, things like that. There are a number of different ways to convert this. They're all documented. If you are looking at setting any of these up in particular, if you're interested in a particular method, please feel free to check in with our tech support team. We can sometimes provide some guidance on which options that might work the best for your particular scenario, simply because there are a number of different ways that folks have their network environments configured and their work groups happen to actually do their work. The last thing we want to talk about here today, before we open it up for questions, is under the Datasource menu. This is where we bring in all of our customized definitions. You can manually define anything in here, but in particular, one thing that folks in the oil and gas realm like to work with are importing coordinate systems and various object types directly from the Epsg registry. Now this depends on an online connection. I tested this earlier today, and the servers were up. The Epsg registry is hosted by servers in London in the UK. So there is always a risk that this service might not be live at the moment I select something. But this brings up a list of all of the different types of objects that we have in the database. So you'll see all the various types over here. And what I'm going to do is click on Datum Transformations so we can see some good examples. Now, you'll see the list here building in the panel on the right. You'll see some objects in red that say exists in data source false. You'll see items in black, exists in data source true. And you'll see all of these various things populating the list, and the progress bar as it slowly downloads the current list of definitions from the Epsg. Now, once those are complete, we can actually query any of those, and we can directly bring those into our own localized database. This is running it's taking a little bit longer to download. I think the connection has maybe slowed down from earlier today. That usually goes much quicker than that, but it depends on the current internet traffic and who else is hitting the server at the Epsg and all that. But what we can do here is simply sort by any of those columns. So I'm going to click on the Exists in Data Source column, and it's going to bring all of those transformations right to the top of the list for various transformations. And so you'll see there are a number of types of transformations here that have been added to the database since we last synchronized. We're going to be synchronizing again soon. With our next release of Calculator 2014, so those will all be black again once we've updated there. But you'll see there are a number of these transformations that we can take a look at. Some of these are going to be different vertical transformations. Some of these are going to be different horizontal transformations. But we can very quickly take a look at any of those different types. So that was datum transformations. We can take a look at ellipsoids, take a look at all of those that are found in the Epsg database, and easily compare whether or not we have those particular definitions. Now, if we get to a datum that we don't have that is supported, or in this case, rather, an ellipsoid, we can click on any of those, and we can simply say, let's show the details for that particular system, and it will pop open a panel showing the parameters that define that particular object. If we don't have a particular item in the system, you can right-click on it, and you'll see there'll be an option to import the object, and that's going to be grayed out for anything that we do currently have. All we have to do is right-click on a particular definition, say import object, and then we'll add that right into your own database. We can then immediately go to work with that system. It becomes a piece of your database, and you can use it instantly in any of your work. So that's the last topic we wanted to handle formally here. What we're going to do is open it up to questions and see what you folks wanted to know about here.
I have one question, Sam, about the updates you just discussed from the Epsg database. One user would like to know where those are saved after they're downloaded.
Oh, okay. The anything downloaded from the Epsg database or anything imported into the database from any source. It doesn't have to be Epsg. It could be from like a PRJ file. It could be something you manually entered. All of those custom parameters or Epsg downloaded parameters are going to go into your custom data file. So that's going to be the custom database that accompanies the main geodata.xml file. So that will be treated as a customized system, and very likely anything that is brought down from the Epsg will be added to the next release of the software. We periodically synchronize with the Epsg database, but they are all handled as custom entities in your local database. Looks like we have a few questions coming in from users. We're seeing a few more. Feel free to keep answering or keep asking any questions that you've got. One simple housekeeping item. Somebody was late joining the webinar. We are recording the webinar, so if you missed a chunk at the beginning, we are currently recording the webinar. Usually takes us a few days to get the video cleaned up, converted over. We post these all right on our website. We embed them from YouTube, so you will be able to view the whole session later on. So keep an eye out on our webinars page. There is a link to previously recorded sessions, and you can also subscribe to our YouTube channel, and that will give you an instant notification once we have uploaded any new video to our webinars channel. We had a question coming in much earlier on seismic data. Looks like there was a question on the specific columns in the seismic data. If C5 and C6 are longitude and latitude, why do they have an N and an E next to those numbers? And the reason for that is that is what's specified in the SEG format. Very specifically, it calls for those. They are usually there just so that you can tell which direction in terms of latitude and longitude you're going. You need the cardinal directions to specify that you are either north or south of the equator or east or west of the prime meridian for use in the system. So even though they are latitude and longitude, they will still be marked with a north-south or east-west attached to those coordinates. Let's see here. On the area calc tool, is the first and last point the same on an area calc? You don't actually have to. That was already answered out there in the chat box. I'll just reiterate that for anybody who's not looking at the chat box right now. You don't have to enter that first point twice. The last point will simply go back to the first point that you've entered in the list to close up that polygon. Let's see, and it looks like our last question coming in is what are the seismic formats? I mentioned there are a few of them. We do have support. Let me actually click back over to the application interface. I'll show some of these on screen. In the seismic survey job that I was working with, I dealt with a SegP1 file. This was the 1990 revision of that file. I've actually got a few others in here as well. We also support the new OGP P111. Some folks call that SegP111, but that is technically the OGP P111 positioning format. I mentioned SegY. That's another one that we have in there as well. Beyond those two that we took a look at, there's also SPS, that's the shell processing system, that's another older positioning file, and UCOA P190s as well. So there's a few of those that we support out of the box, but additionally there are other formats that you can bring in using customized schemes. You can actually add your own ASCII text importers. To bring in basically any uniformly formatted ASCII data, whether it's seismic survey specifically or if it's simply a point database file. A number of folks deal with very raw data in formats like XYZ that simply define subsurface surface grids that are simply an XYZ list of points to create surfaces from those. But the out-of-the-box formats are the SegP111, UCOA P190, SegP190, UCOA P190, SPS, OGP P111, SegY, that's the binary version, and SPS. If you have any need for other particular formats, definitely feel free to let us know about those. You can always add suggestions to things you want to see in the application or supported formats at geohelp@bluemarblegeo.com. That's the address right there on your screen. I'd like to thank everyone for attending today, and if you are interested in Global Mapper or if you're a LiDAR processing user, our next webinar will be next week. We are actually pushing that forward a week, so it is going to be December 17th rather than our usual 2-week gap in between our sessions because of the Christmas holiday this month. We're doing those a week apart. So next week, next Tuesday, same time at 2 p.m., we're going to be taking a look at LiDAR processing in our other main package called Global Mapper. So that should be another interesting session. Thanks everyone for coming, and we'll see you next time.